Hello students, previous class we discussed functions, definitions of functions, how to represent the function, examples examples related to functions also we discussed. Then how to find the domain and range, codomain of a function we discussed. So what do you know about a function? For a function, f from a set A to set B is a relation, you know, is a relation. Which type of relation it is? Such that each element of set A has a unique image in set B. That's so if a function f from A to B, then we can write fx equal to y. So this x comes from this A set, which is called your domain of the function, and this y is the y belongs to your set B, and this B set is called the codomain of this function. So domain of the function is your set A, codomain of the function is your set B, and your range of the function is nothing but your all images. If you are taking an element x from set A, then by this function, which is a rule, by this function f, by the rule f, it is assigned to x, is assigned x by f is assigned to y. So y is the image of x. So here y is the image of x. So if y is the image of x, and if we are collecting all the images for each x belongs to A, that is nothing but your range of the function. So range of the function is collections all y such that f of x equal to y. So in other words, it is nothing but collection of all images of the function f. So far we discussed up to this. Also we solved some problems how to find a function, whether a relation, function is nothing but a relation. Which type of relation? In case of relation, whenever you are considering two sets A and B, then if you are finding a relation, then you are saying that relation R is nothing but your collections of all Cartesian products, such that this x comes from your set A, first set, and y comes from your set B. You know these things. Means in other words, if x is related to y, then those order pair you collect, that is the relation. But in this case, in case of function, what you know, function is a relation, but one thing here you are adding, that is it is a each element has image and each image is unique. That's two things you are adding here. So if you are taking an element x from this set A and it has an image y in set B by this function f, by the rule f. So this y, each element of the set A has an image in set B, and each image is an unique image under this function. If these two conditions satisfied, then a relation is a function. We discuss these things also through examples. You try to solve some more examples so that you will be more clear. Now today we will discuss what are the different types of function, how to find the graph of the function, and then domain and range of the function. Also you can find domain, codomain, range in each function. So different type of different functions and their graphs. Suppose first you will consider a function, identity function. Identity function. Identity function. So let a from real number set R to real number set R be a function such that f of x equal to x for each x belongs to your set of real number. Here R is the set of real number. So if your function is of this form, means your rule is this form, so you can say the function is an identity function. That means each element if you will take from your domain set R, then its image is also same. Its image is also f of x equal to x means whatever elements you will take from this domain of this function, its image by this function will be again the same value whatever you are taking. So therefore, if your function is like this, takes this form, then it is called an identity function. So this type of function f is called an identity function. So in this case, what is your domain? Your domain of the function is the whatever elements you are considering from the given set, that is your domain. So in this case, your domain of the function is your set of real number R, and your codomain is the second set where you are finding the images of this function for each element from the domain set, that is your codomain is your R also. Then what is your range? If you are finding range, C means collection of all the images. Collection of all images is your range of the function. Here in this case, whatever elements you are taking from the domain sets, its image is same. So all elements from the domain set has same image in the codomain set. So f of x equal to x. If you collect all these edges, that is nothing but the elements from your domain set. So here range will be also range of the function is set R here. Now if you will draw the graph of this function, what will be the graph? Graph of this identity function. So previously you know how to draw the graph of a function. In this case, first you are considering a table, taking some values of x. Suppose x value we are taking -2, -1, 0, 1, 2, and this y which is your f of x. This one, let me write clearly here. Y equal to f of x. So since identity function is your f of x equal to x, so whatever element you will take from the domain set, its image is same element. So f of -2, if x is -2, so f of -2 is -2, f of -2 -2, f of -1 is -1. As per the definition of the function, f of 0 is 0, f of 1 is 1, f of 2 is 2. So taking all these pairs, considering all these ordered pairs x, y, now you can plot your graph in your plane. So let us draw the Cartesian plane considering your x-axis. This is your x, so x dash, y o y dash. Let us take the positive values of x, where it is lies. It is lying to the right side of the origin. So let us take this 1, 2, 3, and negative values of x. This is your x axis. So negative values of x, where it is lying, left side of 0. So let it is -1, it is -2, this is -3. And above x axis, that is your positive values of y, the 1, 2, 3. Below y axis, below x axis, it is your negative values of y. So this is -1, -2, this is -3. Now first pair is your, when x is -2, y is -2, so your ordered pair is -2, -2. See here, -2, x is -2, first x is -2, y is also -2. This is -2 and here this is this is your first point. So next is -1, -1, -1 here, and this is your -1, -1, -1. Now next is 0, 0. So 0, 0 origin, then 1, 1, then 2, 2. So next pair is 1, 1, then 2, 2. So 1, 1, then 2, 2. Now if you will join these points, see, this will be a straight line passing through origin. This is a straight line passing through origin. So what you will write here, you can say the graph of an identity function is a straight line which passes through the origin. The graph of the identity function is a straight line, and this line passes through the, let me write here, straight line, and the line passes through the origin. Now similarly another function let us consider, second type. First function we consider is your identity function, then second function is your constant function. So let f from set of real number to set of real number be a function such that f of x equal to, suppose c is a constant, where c is a constant, then the function f is called an identity, constant function. As the name suggests, constant function, whatever value you will take this x value from your domain set, its image is a constant. That is any constant. C may be a positive number, C may be a negative real number. So in this case, if your function takes up this form, where c is a constant, then this is called a constant function. What about this c? You can write this c is a constant, which may be, you write c is a constant which may take negative or positive or zero value. It may be zero also. F of x equal to 0, f of x equal to negative number, f of x equal to positive number, this case. Let us consider this, discuss this. You will be more clear through examples. Suppose f of x is a function taking the value 5, say f of x equal to 5. So in this case, what you will say, c is 5, which is a positive number. Then in this case, if you are finding the graph, what will be this? As before, we are taking a table. Here the value of x, here the value of y, which is equal to f of x, and here suppose -2, -1, 0, 1, 2. Now when x is -2, what is your y value? Y value is 5, because the definition, as per the definition, whatever value you will take for this x from your domain set, its image is the constant 5. Therefore the function is called a constant function. So when is x equal to -1, f of -1 is also 5. When x is 0, f of 0 is 5, as per the definition of the function. When x is 1, x value is 1, then f of 1 is 5. Similarly, f of 2 is also 5. So in this case, here we have taken the values of x only 5 numbers. You can take more numbers also, and other than instead of taking the values of x as -2, -1, 0, 1, 2, you can take any values and real number, any real number, positive real number, negative real number, integer, whatever you can take. Whatever value you will take, its image is constant 5. In this case it is 5. We have taken the constant as 5. Now if you are drawing the graph here, let us take the Cartesian coordinates system, that is x-axis, y-axis. This is 1, 2, 3, 4, 5. This is -1, -2, -3, -4, -5. This is 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. Now when x equal to -2, this is your x-axis, x equal to -2, y value is 5. So first order pair is -2, 5. So -2, 5, this point. Then -1, 5. Next ordered pair is -1, 5. -1, 5. 0, 5. 1, 5. 2, 5. This is 0, 5. 1, 5. Another is 2, 5. Now if you join this, what you will get? It is nothing but a straight line which is parallel to x-axis and lying above x-axis. Since your image is a positive number, so the straight line is parallel to x-axis and lying above x-axis. If you will take, instead of taking 5, you will take -5 here. So means y is -5 here. So again you will, this is the graph of y is -5. Y is -5. This is the graph of y is 5. So you will again get a straight line which is lying below x-axis. Lying below x-axis. Okay, and parallel to x-axis. So this is the graph of y equal to 5, which is a straight line parallel to x-axis, lying above x-axis. If you are taking f of x equal to -5, that means y equal to -5, because you y equal to fx, y equal to -5, the graph is a straight line. Graph is a straight line parallel to x-axis lying below x-axis. Thank you.